All right, well, it's just about noon, so I can go ahead and get us started and make sure we give Ian enough time as participants are filtering in. So welcome all to the Building Simulations Users Group. Happy to be hosting today. I'm Damon Woods, the interim director here. I've got Dylan Agnes here as well, who usually runs our technical support and manages the BSUG program. So for those that aren't familiar with the Integrated Design Lab, if you're coming from IBIPSA, we're happy to partner with them. We are a research branch of the University of Idaho's College of Art and Architecture, and we're really dedicated to education mainly of students, and then providing kind of technical support and technical support and outreach for high performance, energy efficient building design. So, sorry, mouse was doing weird things. So let me go to the next slide. This is hosted, this lecture series, as well as a few of our other programs that I'll mention here, hosted by Idaho Power. So I want to make sure to thank our sponsor. One of the other programs that they also offer is this technical design assistance, which allows our faculty and graduate students to assist, to kind of teach you how to use a new technology or explore some new energy efficiency measures for your buildings. Up to $4,000 worth of our time is free, paid for completely by Idaho Power. These are local projects within the Idaho Power Service Territory. If it's going to be a much larger project than that, then there is a cost share where 25% is covered by the owner, and then the rest is covered by Idaho Power. So check out our website, idlboise.com, if you have any questions or are interested in that. We've got this lecture series, as I mentioned. Excited to have Ian Malloy here today, and then May 19th, we'll be doing IDL will be hosting, and it will be on weather normalization and some climate design tools that we've developed here at our lab back in 2020. So those will be shared with you all next week. For our local audience, we wish we could be in person, but COVID's a thing, so we're not doing that. But you're still eligible to win door prizes. And so be sure to kind of fill out the survey at the end and make sure that you're in the running to win some energy efficiency products for your home. We've also got our energy resource library, which is over 900 tools, an updated website. If you want to diagnose why your building is or isn't working well, we've got the tools for it, everything from light to indoor air quality. We've got some ozone monitors and CO2, the works. And if you're not sure how to use it or what tool you need, we're here to help, so let us know. Idaho Power also has separate programs as well for their energy efficiency program, both new construction and major renovation. So if you're doing a retrofit or you're doing something to address peak loads and demand response, they've got some great programs available, so check out their website. And then as of June 1st, there's going to be a new program rollout, and right now professional assistance incentives, which are separate from the technical design assistance, you can do both. Those are doubled, so up to $5,000 per project and equal to 20% of the incentive. So now is a great time to take advantage of some of those programs. All right, so that's my front matter. I'm going to stop sharing my screen so that our host, Ian, can start sharing his. And I'll just give a quick intro. Since we've got a number of people online and we're recording the session, please just keep your microphones on mute during the presentation. We'll have some time at the end for Q&A. So if you want to send questions in the chat, feel free to do so, or unmute yourself once the presentation is done. But for now, I want to maximize the time that Ian has. So let's get to it. So it's my good pleasure to introduce Ian Malloy for today's session. Ian brings over 25 years of experience in the architecture, engineering, and construction industry, including 12 years at IES and over 13 years at Autodesk, where he's currently the Senior Product Line Manager for MEP and Building Performance Analysis. He's got degrees in mathematics, building science, and mechanical engineering, and is a lead accredited professional. Ian's based in Boston, but works with teams across the world to improve building performance while reducing environmental and financial costs. So Ian, thanks for joining us today, and take it away.
Great. Thanks, Dylan. Sorry, Damon and Dylan, for setting this up and inviting me here today. Really pleased to be here. So yeah, let's get going. There's quite a bit to cover here. I'll just give you a quick outline of what we're gonna do. So first of all, to give just an overview of the tools that are available to you already, if you have a Revit. Well, first of all, if you're a student, you get all access to Autodesk software for free, so you'll have access to everything here. And if you're a commercial user, any subscription to Revit or our AC collections includes all the tools that I'm talking about here as well. So it's very likely you probably already have access to these tools already, but you may not be aware of them, or you haven't explored them fully. Some have been around for some time, some are new. They've all been evolving at different speed over time. So this is a good opportunity to kind of provide an update overview of everything that's possible. My goal here really is to sort of orientate you on all the things that are available and help you sort of understand how you can get started and the kind of things you can do with them. So to break that down a little bit more, I'm going to talk about some of the really key aspects of the workflow. One of the main ones where everybody kind of starts and also commonly gets stuck is around energy model creation, taking a typical Revit architecture model or other starting point and creating an energy analytical model from there, the geometry, so to speak. And then the other aspects of that around the energy settings and the different metadata that's associated with that model in order to run an analysis. And then I'm going to talk a little bit about Insight and its application for sort of concept schematic stage energy analysis. Then I'll get into a little bit deeper around HV system selection sizing with a feature that we call Revit Systems Analysis. And then I'll talk under the hood, a little bit under hood, about how that actually works using the Energy Plus and OpenStudio framework to create your own custom analysis workflow. So I've roughly got about 45 minutes content. We're already a little in. I'll try to leave at least 10, 15 minutes at the end so we can have a good, healthy Q&A. But feel free to put them in as you go, and I will try to get to them at the end. So, okay, so fundamentally, we're really talking about three things, or two things, depending on how you count them. From an energy and systems analysis perspective, there's really two features that live within Revit. One is called Insight, and one is called Systems Analysis. They're both really like a part of Revit. So they're really all just Revit. It's just that they do slightly different things in slightly different ways, right? So one of the ways to think about this is that if you look at the typical kind of design stage, concept through detail or level of development against the kind of level of knowledge or skill that's usually required to do something like this, beginner through to sort of expert. First of all, Revit can traverse the whole lot. A lot of people think of Revit as a detailed design stage documentation tool, which of course it is, but it can also be a very powerful tool early on in the process, especially for energy analysis, because it's so quick to create a 3D model of the building if you don't already have one. Of course, there's also Format, which is available as a pure conceptual modeler that can be used. That is ultimately the Revit file format, so it's one and the same thing. I'm going to talk about everything through the perspective of Revit today, so there's a sort of consistency there. But Insight really sits at that sort of early conceptual schematic stage and more the sort of beginner intermediate level where you're really looking for kind of overall guidance on the project. And systems analysis is the more traditional kind of detailed building energy and systems analysis tool where you've got total control over every single input and output that you might want. Ultimately, that's powered by OpenStudio and Energy Plus. I'll get into that a little bit more a little later. So a good way to think about these is that, if you take any Revit model, you can look at it at sort of any level of detail, or think of it in terms of look at it through a telescope where you get a big picture of overall building energy and sensitivity to key factors like building orientation and window to wall ratio, envelope, internal loads, HVAC systems, and all the sort of interactions between them. Or you can look at it through a microscope on the systems analysis side, where you can take any, one model, any particular geometry, sets of building materials, building and space type properties, load profiles, things like that, as well as mechanical systems, and then run a very detailed analysis on that. So they're sort of two sides of the same coin. They have different kind of use cases. One thing to know is that currently they use the exact same analytical model. So when I talk about the Revit geometry analytical model, Insight and Systems Analysis use the same thing, which is great. They do at this moment in time, they use different engines though, right? Insight is powered fundamentally by DO 2.2, which runs on the Green Building Studio cloud. And Systems Analysis runs locally on the desktop using Energy Plus and OpenStudio. You'll see we've talked openly about our plans here, is that to obviously connect those two things together, but I won't be getting into that today, right? So that's just a quick orientation on the key tools that are available. You can think of it, there's Revit, there's Format, but then there's Insight for early conceptual schematic analysis, and Systems Analysis for more detailed energy modeling and system sizing and selection. So to walk you through all of these and to give you, I'm not going to go through click by click, so to speak, but I do want to give you like a good orientation of everything that's there. I can send more links later around for some more detailed classes and webinars and other material on this. But I'm actually going to walk you through an actual example project. And so I'll call this a real world project. It's as real as I can make it, right? Like at Autodesk, we don't actually do design, right? Our customers do design, you guys do design. But we do obviously receive a lot of models for people who do projects, but we can never would share them, right? So every now and again, though, we do get our hands on a data set, a model, project model. We actually acquire the rights to it, where we can actually use it for, demonstration and testing and things like that, and sort of share it more openly, so you can see it visually how it works, and it makes better than just a sort of a simple box sort of demonstration. So this is actually a real project that's built now. It's the East Residence Hall in Lawrence Technical University. What we have here actually is what the starting point is that I used. I go through the whole, repeat sort of the whole process on, is essentially a fully DD/CD stage Revit model for both architecture, MEP, and structure. Okay, and that provides us with a really good real world use case with real constraints, real goals and objectives to go all the way from early conceptual analysis all the way through to detailed energy analysis and system sizing and selection. So that's what I'm gonna use this example to walk you through step by step. So now the first major piece that everybody kind of stumbles on, it's like the one big stumbling block, it has been for many, many years for a lot of people, is really this gap between a Revit model, which is typically designed for documentation, coordination, detailing, things like that. It's not specifically designed for analysis necessarily. And using the data in that model to automatically create or partially automatically create what we'll call an analytical model. Now, most people will just say an energy model. That means everything, right? But what we're really talking about here is like mainly the geometry, but it's also just to sort of differentiate a little bit. Revit has this concept of a structural analytical model. So to just be consistent with that, we use the term analytical model. So there's a number of ways to do this. And the way you go about doing this depends on sort of what your starting point is and what your goal is, right? I'm going to get into this a little bit more. But really the goal here is to essentially take from the architectural model, and if present, whatever is useful from the mechanical analytical model, to essentially create what we call analytical spaces, which are essentially discrete volumes of air that gain and lose heat from one another, and the analytical surfaces, which are the paths of heat transfer between those spaces. That's what an energy model geometry actually is. That's like the anatomy of it, the main parts. A lot of people would use the term thermal zones for analytical spaces, but thermal zones are just the process more of discretization of a whole building volume into levels and floors and perimeter and things like that, perimeter core and so on. So I'm going to get into this a little bit more. But in order to sort of start to explain the number of different ways that this can be done, the first thing to kind of think about is actually your sort of Revit project setup options. Like, what are you starting out with? Because these things will have an implication for how you do this automatic creation of an energy model. And it all depends really on what your sort of starting point is. So if you're starting with, for example, nothing, you're either at a very, very early design stage, or you don't have anything, you just want to even just try something out, Or you may have some DWG or PDF or other 3D model that you want to use as a sort of starting point of reference. You could be early in design, or you may have a Revit model. And I'm going to call it the architect's model, meaning it's not your model, it's a model that you got from somebody else. So you don't know what's really in it. You don't know how it was created, what the different practices were with how things are structured and created, and what data's in that model or anything like that. So there's a few different starting points here. Now, if you're starting with sort of nothing or some other 3D model, the obvious thing here is that you will start a new Revit project. You can insert or link any CAD reference that you have, and then essentially model your own model. And this is where you can do anything from conceptual massing through the building elements and spaces. People tend to think that in order to do an energy model, you need to do a room by room sort of detailed thermally zoned model. That's true for certain objectives of energy analysis, depending on what the goal is. But certainly for earlier stages, you can get a tremendous amount of value simply by just creating some conceptual massing and levels, which is very easy to do in Revit. And then start to skin that building out by sort of applying walls to the faces, applying percentage glazing, applying curtain systems, starting to detail the interior layout and things like that. Remember, the idea is to do analysis early and often, right? And to try to get ahead of the architecture in many ways, not just wait until it's finished and then do the analysis where it really just becomes a documentation exercise. So we're really trying to sort of facilitate that workflow. And particularly at those early stages, you may not have a Revit model to begin with. And so the point is, it's very easy to create this, right? If you're not a Revit user, there's a lot about Revit that is very complicated, but it's for basic kind of building modeling, it's actually pretty simple, right? And you can learn it pretty quickly. If, however, you have a model from an architect or from somebody else, you can do a similar workflow. And I would suggest before you kind of sort of jump in and try to attempt anything more complex than this, it's always good to sort of think about it this way, is the fact that you can also essentially just treat that model much like the others as a reference, link them in, and you can copy parts from it if you want, or you can just remodel it again, just use it as a reference. Because even though you might start with that architect's model, you might only want to create a conceptual massing energy model of that building, which would take you 5 minutes as opposed to an hour if you want to sort of think about it that way. Of course, the ultimate really is to take that model and be working in collaboration with the architect and the other engineers on what we call a work shared model. And that's entirely possible, but that's a sort of a very trusted space in a BIM process environment. And you really need to know what you're doing there around how the different elements are used and what gets created in that model versus in the central model and so on. So that's something I would always suggest you want to think about graduating to, right? Once you know how to do the basics and how to how the different ways to create an analytical model from elements of where you want to create that, like in a separate model or in the center model, you can do it that way. So that's the sort of most advanced. And then the sort of other in between is kind of like to create a separate copy, right? So if you're wanting to create a detailed model from a detailed architectural model, you can just take that model, break it down to pieces, remove the pieces of it that you don't want, and just use it that way as well. So any sort of variety, there's a lot of sort of variation in here as well. That might seem kind of obvious to some, but it's often not. A lot of people don't know where to quite get started, and they don't want to. We often hear, like, we don't want to mess with the architect's model, and that's true, right? You don't want to go deleting things on them, or even having to delete things or remove things or clean it up, so to speak. What you want to do is be able to selectively use what you want, remodel what's needed as necessary, what's missing. Because, for example, the architect's model at an early stage might only have all the walls in the building and no floors or roofs, because they've just been working in kind of 2D layouts. So everything sort of varies. You need to think about that, and everybody creates models differently. So that's the first thing to consider. Now, while I'm on project setup, the next thing I'll just sort of mention is the fact that as early as you can, as soon as you can, just set the building location and the weather data to be used. Once that's set, you can kind of forget about it. By setting this, you set the building location. That obviously influences things like solar insulation and so on, based on location on the planet, but also the weather data that you're going to use, the climate data. And there's a database behind this that basically provides all the classic kind of TMY climate data, as well as a couple of actual meteorological years for different locations. So you're generally not too stuck for climate data to serve this. And you'll see later on more advanced things you can do here. So in terms of creating that energy model, there's the first thing, and this is one of, again, I'm highlighting some of the most common things people get kind of stuck on in Revit, is that if you look in energy settings, you'll see a setting called mode. And there's a lot of confusion around this because there's a number of different modes in there. Some are older than others and some are newer than others. Some are more advanced and so on. And really, there's really two that you really want to consider or look at, right? And ultimately what these do is they set basically the elements, like the walls, floors, roofs, windows, or conceptual massing elements that get used in the model creation. And then also the method of geometry creation. And so basically the two methods that you have here are use conceptual masses. It does exactly what it says in the tin there. It's basically anything from conceptual massing all the way through to building will be used for energy model creation. So you can really mix and match that. That's really the most flexible and it's the most sort of tolerant of methods. And then the use rooms or spaces one is exactly what it does. It uses the rooms or spaces, which are 2D objects, and essentially projects them up. It's a fundamentally different geometric method to create an analytical model. They both have different sort of pros and cons, right? The top one is a lot more robust, more tolerant to gaps and things in the architectural model. It's very, very fast to create that model. The downside of it as well is it creates a bigger, more complex model than you really need sometimes. Therefore, the analysis can run a little bit more slowly, or it can look a little funny sometimes. People get put off by that, even though it's accurate. And then the rooms and spaces, it creates a cleaner, more airtight model, but it can often have some issues with sliver spaces and things like that. They're the two main methods. You know, you can explore them both. You'll see different mileage depending on what your starting point is. I will say the rooms and spaces really kind of does sort of force you a little more to remodel the building if you're comfortable with doing that. The use conceptual masses really saves you having from doing really any modeling So yeah, that's basically that method there. And then the other aspect that's worth being aware of while we're at it, because depending on the method that you use, there's a few different way that the different other settings around the energy model works. The other next one is around material thermal properties. And again, some people get confused about this under settings, but there's basically a hierarchy here where the conceptual types are the default. There's a thing called schematic types, which is just a longer list of types that apply to the whole building. You can override, which override the conceptual. And then the detail elements, that is, if they are present in the model, I mean, there may be walls and floors and roofs in the model, but they may not have thermal properties associated with them or the correct thermal properties associated with them. If they're in there and you enable that setting, it will override both conceptual and schematic. And the reason for this is that the first two are kind of like type based. You can set them for the whole building. All walls, all floors, or roofs are this type. But if you want to get more precise around this, the south elevation has brick block XYZ insulation, and the north facing has a different type of construction, or even on a single elevation, you have different constructions. You can use the building elements to define that more precisely. So it means that you don't have to work with very high precision models or model elements early on in the process. You can work with more broad brush things to do that. So okay, and then that, and then the other big thing to know in energy settings that again people get confused about is the building space type data, right? So fundamentally, the building has a building type which defines its occupancy, lighting, equipment schedules. If you don't set anything else, all spaces in the model will be assumed to be of that, follow that profile, so to speak. But then of course you can also use spaces in the model to differentiate between different rooms. So this is more appropriate and necessary at sort of detailed design stages when you're differentiating between a meeting room, an office, and a corridor. But at early design stages, it's sort of overkill. You don't need to do that. And you certainly don't need to place spaces in every part of the building. You could just place them where, like if you know it's fundamentally an office and all rooms are so many watts per square foot and so on, but you do have, let's say, a couple of IT spaces where you want to define some significantly different loads and things like that, you could just place spaces in just those areas. So again, it allows you to scale the level of detail, and not just with the geometry, but also with the materials and also with these space type settings. So that's kind of an introduction of sort of like the setup of, you know, you're going to get going with a Revit project. There's a few different ways you can work. There's a couple of key settings that will essentially dictate how whatever's in your Revit model or the Revit model that you have linked gets used in energy model creation and then the subsequent analysis. Okay, so that's a kind of an overview of it, and I'm going to give you a sort of a step-by-step view of what that actually looks like with a worked example right now. I have to apologize here. I have a problem with my PowerPoint. I don't know if anyone else has had this recently. I was back home in Ireland for a while in Europe, and I believe it's something to do with Microsoft removing Windows Player from from Windows to some anti-competitive thing. But this won't play. See, it's the codec cannot play. So I'll just have to play these separately through just Windows Explorer. So it's a little messy. It's not all built in, but we will do this. Manage this way. So this is the first setup of basically starting a brand new Revit project, right? In this case, I'm actually, okay, I'm going to first set the building location. Once you set the building location, you get a selection of weather files to pick from. And then the first thing I'm going to do is I'm actually on the basis here, I've got an architect's model and I'm going to use it, but I'm not going to try to start off by using it in its entirety to do an analysis. I'm going to start much like it's just a CAD reference where I'm just going to use it as a reference. And I'm going to sort of remodel a little bit of the building or essentially use conceptual massing. So this whole example and workflow really works from the very earliest stages of design. Even though we've got a detailed design that we're starting with here, I'm kind of retrospectively going back and say, what would it look like if we did a conceptual energy analysis, schematic model, and so on. So what I've done here is I've created a new Revit model linked in the architectural model. I'm just setting up some views so that I'll be able to work in. So the architectural model as a reference is on the left and my views are on the right. You'll see I also did a thing called copy monitor. That's totally optional, but what that allowed me to do is essentially inherit the levels that are in the architectural Revit model into my model. So it means I'm synchronized. And it means that I'm going to be able to create the energy analytical model in essentially the exact same XYZ space as the architectural model, okay? So that's the first step with that, is just basically just to give you an idea of that could just as easily be a DXF or a Rhino model or anything like that, just as a outline reference that we want to use to create our model against, right? I'm going to show you later how you can actually use the entire model or parts of the model to actually create a more detailed model. So don't worry about that too much. So that's the first video. Next one is then let's start doing some mass modeling. So now that I've got my project set up, I'm basically just going to use some massing. So a lot of people don't know about this in Revit, but it's basically a solid modeling environment. So in other words, instead of modeling walls and floors and roofs and creating a building, you can actually model the entire kind of footprint of the building with an outline and extrude some shapes. You'll see here, I'm basically just tracing out the fundamental footprint. I'm able to extrude them, push and pull them, join them. Essentially, what I typically do here is you create a single mass that kind of creates a reasonable representation of the overall footprint. You can get as precise about this as you want, right? You can even get down to remodeling it on a room by room basis if you want, but that's kind of overkill for what conceptual massing is intended for. There's better ways to do that. What you'll see there happened is the fact that we're using the project levels to divide that mass up to give me the exact same levels and heights in the building as the architectural model. So then from there, I can then create an analytical model. And that's basically a one-click operation based on the settings. And in this case here, I'm using conceptual masses and building elements. And what that will do is that will create an analytical model directly in my Revit view. And what I can then do is I can then use Revit views to kind of interrogate that model and see what it's actually comprised of. So what you'll see here is these are the analytical spaces. So, you know, where you've got walls, floors, roofs, and windows in Revit, they may not be actually modeled or used as like walls or floors can sometimes be used as roadway and things like that, right? So how do you kind of differentiate that? And what this does is it does a pretty intelligent translation of that, and it's able to interpret when a wall is interior versus exterior, regardless of its function setting and so on in Revit. It basically does this sort of 3D scan of the building and interprets where things are. And in addition, it'll also provide perimeter core zoning. That went by kind of fast, but these are the analytical spaces or the thermal zones, so to speak. And if you actually see here, they'll be highlighted just very briefly around the way it's subdivided a sort of a 15-foot perimeter core zone, and it's divided those up. So it automatically does that for you, which is, you know, pretty much good practice for any early stage model. And then it'll also create all of the roofs, floors, and windows, and you can view these in Revit schedules and things like that. So it's really important. And this is a little bit beyond just that conceptual massing model. It's sort of more schematic. I'm going to show you this a little later on, but it's giving you an idea of what gets created in that Revit, in those Revit views that you can then use. And again, like any Revit view, you can cut a section box, you can view on plan view, you can change the colors of the surfaces and the materials to kind of suit whatever way you want to view the information, right? Or view the model and sort of interrogate that model. That's where a lot of personal preference comes in. And this is just using a template that I've set up with my kind of preferred sort of settings. So with that model now created, or any model, any level of detail, but I'm going to kind of go back to the conceptual one, I can now sort of generate what we call generate an insight, right? So there's a little bit of sort of marketing speak here, rather than run an analysis, but it's just trying to differentiate it a little bit. So what we mean by generate insight, in Revit, you'll see a button on the Analyze command called generate. If you click that, it will say, do you want to send this to the cloud for analysis? You say yes, it'll upload the model. You'll get an email saying your model has been received, and we'll let you know when it's complete. Depending on the size and complexity of the model and how busy the server traffic is, it'll take anything from a minute or two to return that email and result, or maybe an hour or two for a very large complex model, or if there's a lot of traffic. Well, you'll get an email back that says, hey, follow this link and we'll show you your results. And that will then take you into Insight, which is actually a browser-based thing, so that you launch the Insight website or browser, and you go into your, you'll see your project there. And from there, you can explore the different, you'll see the key metrics like energy use and cost, and you'll see the standard set of factors that it analyzes your model against. And so what that looks like, if you haven't seen it before, and again, I'm lacking a video player here, so I just need to go back to my little list, playlist, Insight. Again, this moves very, very fast. So I'll try to explain it as we go. So basically what you'll see here is the view of the analytical model. You'll see at the moment the metric that it's showing is energy use intensity. You can flip that over just by clicking it to give you energy cost, and you'll see all of the factors will change. But if you look down through this list, what we have is there's about 24 key factors or things that influence building energy. And these are all sort of essentially scales against which we have tested and weighed the model against, right? We basically run, if you look at that little triangle, that's whatever's in the Revit model, either from conceptual through the detailed geometry or any of those material settings. And if you do nothing, it'll generally sit in the middle. Like default settings are generally medium performance, right? And that's why you'll see that little triangle setting there. What Insight does as a default sort of posture is that it presents everything as an entire range, meaning the only thing it's really taken for granted is the location and geometry, and it's varied everything else. It's run a few hundred simulations in the background, and we've developed a way to try to do the sampling and scaling of those to kind of fill in everything in between. So what this actually presents you with when you look at these results is, when you look at these scales, what you're seeing is relative sensitivities to the overall building energy to each of these factors. So that you can see for window to wall ratio on the south facade, as you would expect, is reasonable sensitive. And if you increase the window to wall ratio, like go to 80%, you'll see the energy goes up. And if you reduce it, it goes down, right? So this is reducing the glazing type. And you'll see some really interesting interactions here. If you make the windows bigger, the glazing type counts more. If you make the glazing type better, the glazing ratio doesn't count as much. Shading doesn't have as much of an impact. And so what it really eliminates is this case where you create a model, get an analysis, and then randomly go back and change 1 or 5 or n things, and then try to do sort of some comparison and delta. Comparison is built into the user experience. And ultimately, what it allows you to do is create what we call scenarios, which is essentially some combination of factor settings. You could start with kind of very broad range, low performance, and incrementally kind of say, hey, what if we upgrade the envelope? What if we upgrade the systems? What if we upgrade the envelope and the systems? What's the relative improvement of these things? And then you can also got some very broad brush things for adding in photovoltaics, like based on percentage roof payback and things like that. So we really tried to design it to be as kind of like as sort of complete view of the whole landscape of all the key drivers as possible. And we worked really hard on making sure that this is highly accurate without being overly precise. And that's a difficult concept for a lot of people. A lot of people confuse those two concepts. It's kind of a flaw in human nature, if you know what I mean, to confuse precision with accuracy. You know, you see decimal places, it must be accurate, when in fact that's not necessarily the case, and so on. So what Insight tries to do is keep you focused on that. At the end of the day, energy use intensity, you know, 2 decimal places. Anything beyond that can't really be measured. What it's really trying to show you is the relative sensitivity of things. So you'll see, for example, the law of diminishing returns with how much insulation you'll add to the building and so on. The thing to know about Insight always does a fixed range of analyses in the background, but your model is entirely customizable, right? Your model can contain any level of detail on the building geometry or the building materials or the internal loads and space types and so on. Insight will do a range of HVAC systems, but for Insight, it doesn't incorporate the piece of information that we add in for systems analysis. I'll talk about that a little bit later, but it does provide a broad range of high, medium, and low efficiency electric, you know, fossil fuel heated HVAC systems. And so we've had really good validation around this over the years, around the level of accuracy that provides with relatively simple inputs. I'll show you some data points on that later on, which you'll see interesting for how it compares. But everything I did and showed you there was just from a single conceptual mass model. Doesn't need to take long to create that. You can create something like that very, very quickly, and then get a very rich data set back that you can use to sort of do early targeting, feasibility, and sort of tracking and trade-offs and so on, and have a conversation with a design team or an owner. It's really intended from like day one to be used. And you can use it throughout the whole process for kind of tracking overall progress, but you invariably can then sort of get into systems analysis later on. So to sort of follow the story along then, what I did there, if you remember, is I started actually with the detailed architectural model, right? Which I can absolutely create a detailed energy analytical model from, and I'll show you that here. But I don't have to, and that's not necessarily practical or useful early on in the process. So what I did was I used that simply to create a sort of an eggshell what we call shoebox model of that building, from which I created a thermally zoned whole building energy model, you know, 40% glazing on it. That's what gets submitted to Insight, and I can use Insight to then explore sensitivity to window to wall ratio and different orientations and different envelope properties and things like that, right? The natural thing to do then, if you're following this kind of workflow, and you don't have to follow this workflow. This is one of the best workflows from a design process perspective, and it's also the best workflow from a learning perspective, right? Everybody tries to dive in and tries to analyze their most detailed model at the most detailed stages. We always sort of say, you know, try and sort of take sort of baby steps. So the natural thing to do here would say, okay, now that we have that conceptual mass model, let's model or bring in the sort of like the feature curtain walling in this, because elsewhere in the building it's pretty much a sort of broad brush 40% glazing. So here you can start to see where you can mix level of detail and level of development very easily, where we've got the sort of feature curtain walling in the model, and you'll see that's reflected in the analytical model, where earlier we had you know, 40% glazing on that ground floor, for example. Because we've now modeled curtain system on that wall, when you create the analytical model, the curtain system overrides the original conceptual default setting. So this is kind of a principle that happens here. So, and then beyond that, you can very quickly create a kind of a detailed model or detailed element model. Note, there's still no interior kind of layout or anything in here, but we are seeing now the fact that you've got a rough window design and so on. You'll start to see the analytical model is getting more precise, more reflective of whatever it is you've modeled. Notice it's still doing sort of perimeter core kind of zoning here. And then the next level of detail beyond that, remember, these are just example steps in a process that you get different levels of detail, where this now has a pretty much sort of is like about as, this is about as detailed or precise or accurate as a typical energy or HVAC loads and sizing model will get you, right? Where you see the way it's broadly zoned. And we've got the window layout design, and you'll see again, the analytical model will essentially give you a one-to-one copy of whatever that level of detail is, right? And then if you can get that far, once you learn that far and you learn how architectural elements and conceptual massing can be used on their own or together and with or without rooms and so on, and how that's used to create analytical spaces, you're then in a much better position to deal with, okay, I've got this big architectural model, complex model from an architect. How can I do an automatic translation of that at a very, very high level of precision? You can absolutely do that. And here, what you'll actually see is every individual space has been taken off. It's normal practice in energy modeling to kind of group a lot of spaces that are on the same zone or thermostat and or the same sort of usage and things like that. And that's perfectly fine. In fact, in many ways, this level of detail is not actually even required. Yet it's what a lot of people try to achieve, thinking that this is what they must do to achieve an accurate energy model. When in fact, that's not actually great. Something like this is probably better, somewhere in between. But the key thing is here is that once you know the tools, once you understand the basics of Revit architectural elements and how this and those energy settings modes and how that geometry is turned into an energy model, you're on your way to really being able to work the way that you want to work with a wide variety of projects and levels of detail. So one of the things I think that's really interesting about that is if you take those 4 or 5 levels of detail that I had from conceptual massing through to sort of fully detailed, and you analyze them in Insight, where Insight is going to analyze a range. It's going to take whatever's in your model, but remember, whatever's in your model is only one potential possible outcome, so to speak, based on all the other things that can go in as well as your geometry. And so one of the things that you sort of hear is that, well, people think that shoebox model then can't be that accurate and so on. Well, in fact, if all other things are equal, if you apply the same sort of building type, space types, envelope properties, et cetera, you'll actually see that this is just the EUI for all of those. You'll see they're within a couple of percent of another, not only the mean, the big number, 115, 118, but the max potential and the min potential energy use intensity is also the same as well. So you'll see it really allows you to pick your level of detail, not just on the geometry, but also on the decisions you need to make around things like building envelope materials, internal loads, and system type, and so on. So the next step now, another little video, is to go a little bit deeper into, let me just go back so I can see where I'm at with my content, is to look at get a little bit deeper into what we'll call more detailed traditional sort of energy systems analysis, where instead of doing a range of analyses and using Insight to do a range, we're going to analyze one in a lot more detail. And at the same time, we're going to control that model in a lot more detail. Now, Revit already has the ability to model geometry at all levels of detail. And in combination with that, the materials and the internal space by space properties at lots of different levels of detail. The one thing that's traditionally been lacking is the ability to define what we call an analytical system. Now, what we mean by that is that, you can certainly model ductwork and pipework in Revit. I mean, that's its main use case for things like coordination and documentation and so on. But you would never want to or have to, model the entirety of a VAV or a fan coil just to analyze whether it's more energy efficient than another, because you only need those sort of topological kind of settings. So systems analysis fills that gap. But first and foremost, what it does is it basically does what we call an ideal loads calculation. So even if you just take that Insight model where you've got your geometry, your location of materials, and you run systems analysis, you'll see there's 2 choices: a single annual building energy simulation or a single HVAC system loads and calculation. You run that, it'll run on the desktop, it'll give you a little notification when it's complete. Again, this, depending on your model complexity, can take anything from a couple of minutes to maybe an hour or more. A few hours even for a very, very large model. Energy Plus is a little slower because it's doing a more thorough analysis. But from there then, sorry, it's hard to keep track jumping between PowerPoint and, here we go. The video, you can see, get your load calculus out, right? And this is a little bit further. This is including the systems analysis. I'll play a little video for this later on, right? But what this will show is pure space by space peak heating and cooling loads for each space that you've defined in your model. If you define analytical systems, it will also add in things like what's your load in your boilers, chillers, air handlers, fan coil, VAV units, and things like that, right? And that's really where we get into what we call analytical systems, okay? So again, I have to play a video for you here to illustrate what this actually is. So yeah, this one here. So first of all, let me just pause this. So the first thing to discover where this is, if you open up the MEP system browser and look under systems, you'll see Analytical Systems. You have the ability to create essentially zone equipment like fan coils, VAV, VRF, as well as air and water loops. And essentially allows you to create the relationships between them. And then once you do that, you can then basically use this concept of what we call system zones, which is basically kind of like a BIM-based version of the kind of markup that an engineer typically does and say, these regions are served by this air handler and or these sets of VAV boxes. I want one VAV box per space or that grouping on that space. So it's a way of actually sort of capturing that design intent for a particular very specific system design, right? And so again, you can be as broad brush about it as you want, like, hey, just draw a box around the whole thing and say all spaces have their own VAV. Or you can say there's a north, south, east, west sort of zone and things like that, right? So it allows you to actually sort of capture that initial overall sort of system topology. And it's basically here using the Energy Plus schema. All the objects that you see in Energy Plus and OpenStudio schema are essentially what's represented here. And then once the energy analytical model is, sorry, I played these in reverse a little bit, I think. So this is actually showing you, sorry about that, creating the actual like a water loop, right? You can create a condenser water loop, and then you create a chill water loop. You can say the chill water is water cooled, the condenser water loop, and then hot water loop. You'll see how it comes together now. If I create an air handler, and this is, let's say, a VAV air handler, I'm going to say it's served by chill water. I pick the hot water loop. I can set it to be variable or constant speed fan. Then I can create a VAV box, one per space, with hot water reheat. It's served by that air handler. So I can create the sort of objects and relationships between them within Revit. And then that's when I use what I just showed you a minute ago, the system zones, to actually connect all the logic up, so that when you create your analytical model, this is what you end up with. If this is the video, I think it is. Yeah, so this one is sort of widescreen, because for this particular model, you want to be able to see the 3D model, and there's actually 5 levels in this building. And so what it's actually done here is you'll see all the little zones that are marked up, saying like those, if you just look closely at that, you'll see those 4 or 5 spaces there are all on a particular water source heat pump. And to explain a little bit about this building, because it's a real design that we've kind of mirrored here, is the fact that it's water source heat pumps with the dedicated outdoor air system, energy recovery unit on each individual kind of leg of that building. So if you look at the actual analytical system sort of tree and the spaces that are getting highlighted as I pick through this, you'll see heat pump 1, 2, 3, 4, 5, 4, 5, 6, each sort of zoning. Here you'll see all the spaces served by the dedicated outdoor air systems. Then you'll see just the dedicated outdoor air system on the, east wing. Then the ones on the west wing, or north or south, whatever it is, I think it's east or west, is in this building. And then you'll even get down to things like there are some fin tubed radiators in some of the common areas, and there are some electric unit heaters in the vestibules and things like that, and in the staircases in the bathrooms, and each main component of the overall mechanical system. And again, this actually reflects why you don't want to get to this level of detail early on in the process, because it's only one system that you're analyzing, and it's a bit time consuming to define it. So this is more typically done at detailed design stage, where I'm sizing, I've decided my system type, I'm going with this particular zoning strategy, I've chosen to group things in this way. That really provides the basis of what then gets sort of modeled downstream from that, right, in terms of an actual physical MEP model. So again, let me just see where I am here. And then yeah, let's just play this one. I think this video is a little old. Yeah, so then once I've done that, I can do 2 things. I do whole building energy analysis. I can also do loads and sizing. So you can hear, I can see my system, my zone loads. I can pick, that's my heating and cooling on a zone by zone basis. Then I can pick on the system loads, and you'll see that's the energy recovery unit 1 and 2, and I can see the loads on that on the overall sum, as well as the psychrometrics and things like that. So this is a new feature that's actually now in Revit 2022. It's brand new, out only a couple of weeks ago. This is all built using Energy Plus and OpenStudio. And the reports, they work in both metric and IP units. They're supported in all the languages that Revit works with, but critically, it's all entirely customizable. You don't have to, be tied into the way this report works. If you wanted to add another column in here for any additional reason, that's where you can use the OpenStudio results measures to actually add those in and customize the report a little bit more for you. The same way as you can every other aspect of the actual analysis itself, because we really tried with this feature to minimize the number of parameters that you need to actually add in Revit. We really just wanted to add the minimum object model in there and have all of the properties that are associated with things like COP of PTAX and things like that, all derived or all defined in the OpenStudio measures. So I'll actually just show you this a little. I have a better version of this here. Very quickly, this is the video that sort of explains the new loads analysis. Here they have to use in the rooms and space mode. So obviously we've got a space by space model. Let's generate the geometry. You'll see the zone load summary. There's two things in this. We've rationalized the way the GBXML works. I'll just speed this up a little bit. But yeah, this is basically the loads report. It's built into Revit. It's basically a separate Revit view, but it's also a HTML report that you can export, create a PDF of and things like that. Critically, is all the data that's associated with that's basically powering this is sort of exported and saved in the background. You can export that separately, and you can open up the model even in Energy Plus. But you'll see the way it is actually a separate Revit view that you can look inside. You could also just open this up in a web browser as well. So really nice, much better than what was there before, which was just the original default Energy Plus output report. So this is a really nice addition for loads and sizing analysis. So where I jump to now. So everything I've gotten so far, I want to leave a couple of minutes for questions and answers. But basically, I've gotten it now to the point where we've done very detailed model, whole building energy analysis, loads and sizing. And obviously, you can get into the downstream physical modeling. And just wanted to sort of explain part of our rationale behind doing this. It wasn't just so that we could provide a way to do this type of analysis in Revit. That's a cool thing to do. The other reason this makes it extremely interesting is the fact that the only reason any of the ductwork, pipework exists or is where it is because there's equipment in that building that's serving a function that was basically decided by an engineer doing the systems analysis, right? So whether we had one water source heat pump serving 4 spaces or 1 space or 2 air handlers, two heat recovery units versus 1, they're key decisions that are all part of that analysis earlier on. That information is now in the Revit model and can be used as the basis to manage that downstream. And that's not an automagical one button thing by any stretch, because everybody creates Revit models differently, manages that Revit BIM content differently, and has different relationships in there and parametric behaviors in there. And it's very much custom sort of content. And because of that, that's where we're allowing people to start to be able to connect that for themselves, right? So again, with some knowledge of OpenStudio and Energy Plus and Revit content, you'll be able to start to connect these things together. And that's our other goal here, is not just provide BIM-based analysis. Doesn't just mean using Revit to do the analysis, but it also means using that information to drive the downstream process as well. So I'll go through this quickly. So, I mentioned earlier with Insight does a whole building energy range, but systems analysis does a single model and use breakdown, right? So they're two sort of different bookends, right? And it's worth being aware of that. Again, that report is built using OpenStudio measures. You can customize it, you can add to it, you can break it down in different ways. But the real power of the systems analysis feature comes from what's under the hood, which is really OpenStudio, the OpenStudio Sdk. And what we call an analysis workflow is basically when you click systems analysis, and you saw earlier where you can pick an annual energy or HVAC loads and sizing. That's what I kind of call a vanilla one, right? It's complete, it follows best practices, but there are assumptions in there and so on, and there's things that you may want to override and change the behavior of. And so all of those behaviors and all that logic is contained in OpenStudio measures or what we call a workflow file. You'll see that in Revit, if you look under file locations for systems analysis workflow, you'll see we provide you with 2. You can go and find them and open them up, and you'll see that's where you'll see the scripting for example, what's happening behind the scenes when you run that analysis is it's actually exporting GBXML, converting it into Energy Plus. It's applying any data that wasn't specifically defined in that GBXML. Like GBXML contains things like geometry and materials and internal loads and things like that, but it doesn't necessarily have, until we create it, HVAC systems data and so on, and doesn't have all of the detailed controls information around that stuff. They're all contained in measures. So you can dig all the way through and see, for example, here are all the properties of all the HVAC equipment. So for example, here's the simplest one. Here's a PTAC. So you can see its COP and things like that are all set in here. It's cooling design temperature and heating design temperature and so on. So you could get another manufacturer's equipment there, change it, and simulate the effect of that. And that's why I wanted to introduce this, is that this is where it opens up the ability to connect, Revit to a totally open back end, right, which is the OpenStudio framework. You can write your own measures, but a lot of people have already created a lot of measures that you can also use as well. You just need to inject them into the workflow. So that's pretty much it end to end. Just a little, that sort of give you a recap of what we kind of cover there of the tools, basically being Revit, insight and systems analysis, automatic energy model creation from conceptual through to detailed, where insight can play a big role for those sort of early stages, discovery and targeting and trade-offs. And then more detailed energy and systems analysis using Energy Plus and OpenStudio with the ability to actually completely customize the way that works, not only for the analysis, but also connect it more into your BIM workflow and your BIM content. So I'm going to stop there. I think, a little short. I wanted to try and leave 5 minutes. So I will see if there's any questions from the Q&A, and failing that, we will take some from the audience. So
thank you very much, Ian. Appreciate it. For the attendees, there was a poll that was just launched. If you wouldn't mind filling that out, we'd appreciate it for Idaho Power. And then if you have topics for future presentations you'd like to see, please let us know. And then Ian, I'm assuming you have access to the chat. We've got a bunch of questions in there. I will let you choose questions at your discretion that you feel most relevant and would provide the best feedback to the audience. So
right.
Feel free to just dive in and start there. And then if others come in just from the audience, just feel free to send them into the chat. Okay, great. Thanks, Damon. Yeah, so I see from Karen, she asks, what tab is energy settings in? It's on the Analyze tab, but if you're not seeing it, it's because it can sometimes be disabled by default by your BIM manager, right? For whatever reason, that's just something that can happen from time to time. So if you go into File, Options, so just to check, you guys can see Revit, yeah? User interface, you'll see down here under energy analysis and tools, just make sure that's enabled. If not, it won't actually appear and you won't see that. So that's that one. Is the Analyzer Insight ribbon under the launch option? Looks like a point chart graph. Not quite sure I understand that, sorry. Possible set. Is it possible to set a custom climate file insight? No, so not Insight uses GBS. What we call climate server. So no, we can't do that at this moment in time. As long as it's an EPW, so choose, yeah, Energy Plus, it's ultimately using an Energy Plus file. So yeah, there's that. See other people who are answering this for me. Thank you very much. It's always hard to catch up on these things. Oh yeah, Autodesk paid for the conversion of Fortran C++. That's right. Why is that why you use OpenStudio measures? Yeah, actually, it's a great question. Yeah, so back in 2013, Autodesk helped the DOE convert Energy Plus from Fortran to C++. The reason for that is that very few people on the planet know how to program in Fortran. A lot more can program in C++. So we helped with that. We basically paid for it to be done, and we granted it. And it meant that a lot more development could happen a lot more quickly on Energy Plus. And one of the things that came out of that was the OpenStudio SDK. So that's kind of, I honestly think of that as being our sort of payback on that, because the OpenStudio SDK allows us to now provide analysis in a totally open, extensible way. You're not relying on us and the way we think you should run analysis, because let's face it, we're great at software, but we're not engineers, right? We got subject matter experts on the team and so on, but we're never going to define the way analysis should be run for every situation, everywhere in the world, for everybody. So connecting to an open source, open project is a really, really powerful way to allow people with really high quality sort of tools and analysis out of the box, but not constrain them beyond that. Granted, it requires more expertise, but or knowledge, but there's no limit on that. Will Insight take neighboring buildings into account? Yes, basically you can do it a couple of ways. Model your building. Any surrounding massing that what we call doesn't have mass floors enabled will be seen as
surrounding buildings and provide shading on the building, or even any building elements that are not included as part of the building, not set as part of the building, will do that. So yes. What else? Can you provide resources for learning how to do these steps? Yeah, I did an AU class 2 years ago that provides an introduction to this, more step by step. There's more time in that, and then there's a second class as part of that Noah Flaum did on under the hood with Energy Plus and OpenStudio and how to start to program that. So there's about 3 hours in total. Kinetic facades, I'll just say out of the box, no. But insofar as how Energy Plus can do that, and there are OpenStudio measures to do that, you could start to analyze that using custom workflow measures. So I'm just trying to go through these questions. So I'm scanning these, trying to find. Why not a simple routine? The boundaries are defined. Oh, okay. So yeah, I can tell you, from when I joined Autodesk and started to look at this problem, I always thought this is surely a simple problem to solve. And it's really, really, really not, because the nature of Revit models and the level of sort of precision or the tolerances for them, little gaps and overlaps and completeness and not. And even if a 2D plan is complete, well, what about when it goes to 3D and starts to extrude upwards? If you've got things like outward sloping walls and double stack spaces and voids and things like that, it's crazy complicated. So we've actually over the years developed or tried a couple of different methods to do things, and what we've really resolved on, there's sort of 2 in there now that function to different levels of sort of completeness, if you know what I mean. The rooms and space, I won't get into that, but it's not that simple. It sounds simple, you'd think it's simple, but it's really, really not. Yeah, so I think that's all the questions that are in the list. I realize we're at time. I don't want to take.
Yeah, thanks. We got one more that you mentioned, that Insight uses DOE 2.2. Does it create a .imp file that can be accessed?
Yes, it does. Just go to the gbs.autodesk.com and you'll be able to download it. That's the engine behind things. Same way as Systems Analysis creates IDFs in the background that you can use as well.
Well, wonderful. There's so much to explore here, Ian, but really appreciate your time today. And I'm excited to see, the integration with some of the OpenStudio measures and the power of some of the custom charts and things that you can do with it. For the audience, this recording will be available on our YouTube channel, and you can access that through our website if you want. We've got another BSUD coming up May 19th, that Wednesday, on some of the free climate analysis tools that we've got here at the lab. Ian, if others wanted to get in touch with you or learn more about these systems or access more trainings, do you have an area that you could point them to? What
I'd say is probably the best thing is find me on LinkedIn. Feel free to connect. I will. I probably should have put it in the presentation, but Damon, what I'll do is I'll send you an email and Dylan an email with the links to the further resources, and you can maybe share them with everybody if that's okay.
Sounds good. Yeah, we can post that in the slides along with the recording of the presentation. So. All right. Well, thank you very much. Appreciate it. And we'll
You're welcome.
Later.